breakthrough projects. In this video, we are going to explain about the project that is predicting hospital stay length using explainable machine learning. Before getting into the execution, first let us understand what is the project about. Think about how as the population grows and life gets more stressful, we are seeing more and more people falling seriously ill, especially with the diseases that impact the heart and brain. Now imagine hospitals trying to juggle all the patients while having limited number of ICU beds. It's like trying to fit too many people into a small room. Some just won't get the space they need in time. When hospitals don't manage these beds properly, it's a big problem. Resources might sit unused when they are desperately needed elsewhere, or worse, critical patients might not get the care they require when they need it the most. It is tough challenge that hospitals are facing, and it is putting the whole healthcare system under strain. And that's the crux of what is being pointed out here. And SOFA and Apache were the techniques that are used to manage the hospitals related to ICU resources. These systems they don't perform that well because the problem is they only look at the basic patient data like surface level stuff and not the full picture of the patient's medical history. So now think about how much more accurate predictions could be if they use all the details all the details of the patients like electronic health records, that is EHR. It contains past illness, treatments, or patients in their health. That's a huge amount of information being ignored. Because of this, the current system can't always predict if someone needs ICU care or how long they need to stay here. It may be short term or long term. Without tools that can analyze all the data, hospitals are left struggling to allocate resources efficiently, which not only costs more but also affects how well patients are treated. So, there is a real need for better solutions that can dig deeper into EHR data and make smarter predictions. So, this project, it focuses on predicting whether a patient's ICU stay will be short term or long term by analyzing their complete electronic health records, that is EHR. EHR contains a detailed account of patient's medical history, which provides crucial insights for making accurate predictions. To ensure the system works with the high quality data, it includes pre processing techniques to address any missing or inconsistent information in the dataset. And this step is essential to maintain the reliability and effectiveness of the training and testing. And the system applies different machine learning algorithms to classify ICU stay. And the algorithms are logistic regression, random forest, gradient boosting, XGBoost, each contributing unique strengths to prediction process. Using multiple algorithms, here it improves overall accuracy and performance of the system, as it allows strengths of the each model to compensate for the limitations of another. This approach ensures that predictions made by the system are robust and reliable, enabling better resource management. And the system's performance is improved through hyperparameter tuning, which involves fine tuning the setting of each algorithm to get the best results. Each algorithm has specific set of parameters that affect how it processes the data and make predictions. So by optimizing these parameters ensures the system performs at its peak. And here, once the algorithms are trained, once the algorithms are tuned, the system is evaluated using various metrics to measure how well it is performing, which includes accuracy, precision, recall, FN score, and AUC. It shows the ability of the model to distinguish between classes. By using these metrics, the system effectiveness is assessed to ensure it can make it accurate predictions and contribute to better ICU resource management. This is the proposed system. Moving to the extension, so to further improve the accuracy, CAT Boost has been incorporated. It is tested to see how well it could handle the predictions. So CAT Boost is machine learning algorithm that uses gradient boosting and decision trees specifically designed to work with the categorical data. It builds decision trees step by step, and each step fine tunes the features, which makes the predictions more accurate compared to the original algorithm. CAT Boost performs better in terms of accuracy, proving it to be more effective for this task. And to make the system more user-friendly, front-end is built using Flask. This interface allows users to interact with the system, test its functionality, and see its performance. It also includes user secure registration, that is authentication, ensures that only authorized users can access it. Overall, front-end is not only It not only makes the system more accessible, but also helps the users to evaluate its usability and effectiveness. Moving on to the implementation of the project. To implement this project, we have followed the steps in the flow of work. So the first step is importing the libraries. Here, essential libraries like Pandas, NumPy, scikit-learn, Matplotlib, and others are imported to provide functionalities for data manipulation, pre-processing, visualization, modeling, and evaluation. In the next step, the dataset is loaded and inspected to understand its structure. This includes features, data types, and class distribution. This step helps us to identify patterns or potential issues. Then comes the data visualization. Graphs and plots are created to explore relationships between variables, detect outliers, and identify trends or patterns that can influence modeling. Then comes the data processing. Here in this step, label encoding has been done. So the first pre-processing is label encoding, which converts categorical data into numerical format for compatibility with the machine learning model. And then we have handle missing values. Here we fill and remove missing data to maintain dataset integrity. After that, we scale numerical features to a standard range for improved model performance. Then comes feature engineering. New features are created and existing ones are modified to enhance the model's ability to make accurate predictions. And then we split the data into train and test sets, where train set is used to train the model and test set is used to evaluate the model. And model building. Here, multiple machine learning algorithms such as logistic regression, random forest, gradient boosting, XGBoost are trained using the training data set. And then those are evaluated using accuracy, precision, recall, and FN score, and they are compared. The results of different models are compared to identify one of the model that with the highest accuracy and best overall performance. And then comes the front end part. The user interface is built using Flash framework with the registration and login features, which is supported by SQLite database to ensure secure access. And in the front end users, they will be able to give feature values related to EHR, and then it will be pre-processed at the back end that will be fed with the train model, and finally output will be displayed through the front end of the application. Moving on to the algorithms used, these are the algorithms which are used in this project to predict the hospital stay length of the hospital stay, which are logistic regression, MLP, random forest, gradient boosting, XGBoost, and extension cat boost model. To implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Let us open the dataset folder. So this is the dataset that we have used to train the models. This is the EHR's length of the stay of a patient. So it's being loaded. Just wait. So here are different records. So here we have different records. Using this data, we have trained all the machine learning models to predict the length of the stay of a patient. So these all are the different attributes based on which length of stay will be dependent. So last column is the target column where we have 0 and 1. They are the short stay and the long stay. Now let's close this. And in this file, we have the test cases that we will be using in the front end to predict the length of the stay of a patient. Let's get back. And in this model folder, we have .h5 files, numpy files, pickle files in which algorithm information is stored. And that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.ipynb file, that is the ICU stay prediction file. This is the Jupyter notebook file, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open command prompt. Here give the command cd, give the space, paste the copied path, and now click on enter. Here if you observe, current directory is changed to the code folders path. Now compile app.py file by giving the command python space app.py, and now click on enter. So what will this command do is it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost, and the port unless configured differently. Now we are supposed to copy this local link provided by the Flask framework and paste it in any web browser. I've copied the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser, and this is developed using Flask framework. Now we need to sign up. Click on sign up and enter all the registration details if you are registering newly. I have already registered. I will directly sign in. Click on sign in. Give your username and the password and click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test case file. So click on that. This is the file that we are supposed to upload. So select it, click on open. Before uploading, let's see what are the features that we have in this file. Let's open the data folder, open the test data. So here you can see parameters, right? These are the parameters that we will be giving as input for predicting the hospital stay. So these are different parameters and these are different test cases. So here the first one we have is EID, that is unique identifier for each patient. And then we have V date. So this is the validation date. That means when the patient has been registered, when the patient has been visited for the hospital admission. And then we have is the R count. It is the record count for each patient in the data set. And then we have gender. It is the gender of the patient, whether is male or female. And then we have it is dialysis renal stage. It is the indicator of end stage renal disease requiring dialysis. And then we have asthma. It is the presence of asthma condition. Then we have iron def, that is the presence of iron deficiency. Then we have NIM, that is history of the pneumonia or respiratory illness. And then we have substance dependence, that is the history of substance dependence. And then we have psychological disorder major. This is the presence of major psychological disorder. And then we have depressed, that means it is diagnosis of depression. Then we have psychother, that is the history of receiving therapy. And then we have fibrosis, another, it is the presence of fibrosis or related conditions. Similarly, we have total 27 parameters that we will be giving as input. Let's get back to the application and now upload it. So this given input will be pre-processed at the backend, and then we will be getting the prediction. So here, this is the first test case that we have given the input. This is the first record of the patient that we have given. So here we got the prediction that patient will be staying for long time. Here it has predicted as long stay. Similarly, this for the second input, for the second test case that we have given, here we got the prediction as long stay. That means patient will be staying long in that hospital. And then here we have short stay for this particular input which has been given. Accordingly, for all the given input that we have given, it has predicted long or short stay. Based on the given input, it will predict the long or short stay. Now let's check with the graph. Click on graph. So here we have the confusion matrix graph of the extension model. So this is the extension model of the CAD boost confusion matrix, and this is the ROC AUC curve graph. And here we have the accuracy comparison graph. So this is the accuracy comparison graph. Here on x-axis, we have accuracy score, and on y-axis, we have algorithm names. So these are the algorithms which are trained for predicting the long stay, that is long stay of the patient. And here we have precision score comparison graph. This is the recall score, and this is F1 score comparison graph. These are the error metrics used to evaluate the model. Now click on sign out. In the switches, by giving input to the system based on the given input of the patient, the machine learning models, they will be classifying whether the patient will stay for long or short. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.